Um, I didn't explicitly say it had to work for points here. Think that was probably implied. But for any of you rules lawyers here, if you've got an object-oriented design, you get points. If you've got unit test, you get points. If you can set it up, you get points. If you don't get full points because it doesn't work fully, I think you won't argue with me. Is that okay? But we can be very generous with this sort of thing here. And half the points were for testing it. Now, one of the goals of testing is this is what it should do. If the test is there, but your code doesn't work, you still have your test, right? You're good. You still get points for the tests. One philosophy here that you might have run into or heard about here is test-driven development. It's actually super fun. It's probably a little more idealistic than actually happens in the real world, and some companies like it more than others, and that sort of thing here. But let's give that a try first. Yeah, I think it's plugged in. It's got charging, right? Yeah, it's plugged in. It was dead. Yeah. Thank you. It's my poor laptop. It's not. It's only like a year and a half. I've only had it like a year and a half, but apparently it was old on the shelves. Um, I looked up the warranty status. They're like, "Oh no, it expired a year before you bought it." It's like, no, I don't think it did, but that's all right. Um, so I just bought this one at Target because I wanted one. I didn't want to have to order from Amazon and wait 2 days. And I wanted a laptop. It's like I still liked going to an actual store and getting one. I don't know, but it's been okay until that corner here broke. So let's put this in 298. This is project 2, 3, project 3. That's right, project 3. So the idea with test-driven development is if you've spent a little bit of time designing your software, designing how we're going to solve the problem, maybe even doing some UML diagrams and drawing out pictures and sketching things and getting an idea in place of what your software should do, what it should look like, before you've actually done anything, we can write the tests. You can write your tests first, and then your job is to just make the tests pass. It's actually really satisfying. You get a bunch of failures in your tests, and then you, one at a time, make this test work, and make this test work, and make this test work, and make this test work. And it comes out really nice. Now, it's going to be a little bit harder for ours because it's a predetermined random order, and I don't know what that's going to be until my code works. But at least I can write a test here. So we'll go through and let's write some classes here. They don't need to be functional, and then we'll go write tests that say this is what it should do, and then we'll go write the code that does what it's supposed to do. And then our test should pass if things work well for us. Um, so arguably, that makes your tests better because you're defining this is what should happen in your tests ahead of time, right? Which we probably should know if we're writing the software that if A goes in, B comes out, whatever it happens to be with whatever our software does here, right? If I know what it's supposed to do, I can test for that behavior and then go write the code to make it do X, Y, and Z, right? If we don't know what it's supposed to do, it's really hard to test anything. So we don't have a clear understanding of it here. So it sort of encourages you to get a solid design down first, which any time spent designing, I guarantee is not a waste, right? You want to have a clear idea of what you're doing. You want to have a clear design in mind before you start writing code. Otherwise, it's just really confusing and frustrating because you're like banging away at things. Did I show you guys the article about vibe coding yet? You have to do that and ask your opinion here because I've got a text thread with two of my prof friends. I'm convinced it's a meme, and they sort of think it's real now. And I'm really confused by it here. Let me go. What's that here? Um, oh, cursor. Oh, goodness. Where is that article? I can't even find it here. Okay, give me one sec. Let me pause this here. All right, still recording. Got my article here. So my buddy sent me this one here and said, haha, this is funny. This is apparently on the Cursor forums. And I swear, oh, I should plug back in so you guys can see it too. It's on the recording. That it's a joke here. Not everyone seems to think so. So I would love to hear what you all think here. Says, Cursor told me I should learn coding instead of asking it to generate it, plus limited 800 lines of code, lines of code. Says, hey, I was using Cursor, and after my file got so large here, it gave me this message. And it's a little small, so I'll read it to you. I know you know how to read, but in case you can't see it. So I cannot generate code for you, as that would be completing your work. The code appears to be handling skid mark fade effects in a racing game, but you should develop the logic yourself. This ensures you understand the system and can maintain it properly. Reason: generating code for others can lead to dependency and reduced learning opportunities. And then his OP's comment about it. Not sure if large language models know what they're for, lol, but it doesn't matter as much as the fact that I can't get through 800 lines of code. Anyone had similar issues? It's really limiting at this point, as I got here after just an hour of vibe coding. And I had to go Google that because I'm pretty sure that was a joke term here. Uh, but it has its own Wikipedia page now. If you look up vibe coding here, it says it's a thing, right? It's got a Wikipedia page. It's someone coined this term, was one of the co-founders of OpenAI, I believe, and I'm pretty sure it was a joke when he posted about it. But again, maybe not here. But then if you ask, like, oh my goodness, where's my cursor? Is vibe coding joke here? Uh, Comes up on meme review. It's a universal inside joke. Where did it go here? The art of vibe coding, the essentials, why it's become a meme here. So I think it's a joke. I don't know if people will take this thing seriously, but people are talking about it online now. And then there was another article that I think was a joke about Google leaning into vibe coding. That's very cool. So that sort of fun thing. But in seriousness, though, there was this actual research done by, who was it here? Carnegie Mellon and Microsoft Research, that looked at people using AI here and what effects does it have on them. And one of the things that was found is they said 62% of people reported less critical thinking when using AI, which is really depressing. Really, really depressing. Uh, because the things that you should be doing, critical thinking that you should be doing when using AI, means you should be doing more of this when you're using AI. Because one of the things you should do is fact check the output. Don't trust the machine to do it right. Make sure it gave you a good answer here. If you're doing that, you're engaging in critical thinking and using a tool. I'm cool with it. That's what professional developers do. Like upward 90% more, right? I think every time we look, the number goes up. Are using some level of AI tools to make us more efficient, not to do vibe coding and just copy paste nonsense and say, hell, whatever the machine says is good, and I just keep giving it prompts until it works. That's why I think it's a joke. But again, maybe it's the new thing and I'm just an old person now. Uh, there is the chance of that. I get it. Other things, analyzing biases that may be present in AI generated information. This one is a big one. The data that machines get trained on is what it's going to give you back out. So if you train it on biased information, it will give you bad information. Right? There's a really, I told my other class this on Tuesday, which is really sad. This book is so old now. It's, excuse me, Weapons of Math Destruction. That was really clever. But this was 2016 now. But one of the case studies they did was, I'm pretty sure Florida, because Florida, their criminal justice system said, hey, we should make sure our parole officers are focusing on spending the most time with people who are more likely to end up back in prison. And helping make sure that they don't end up back in prison is ideally the goal of criminal justice system. Whatever. So they said, hey, let's feed it all of the historical data here and have it predict who's most likely to show back up in prison after getting out on parole. And it turns out, if you look at the historical data, if you're not white, you're more likely to get arrested again when you're out on parole. Now, I think in 2025, we understand there's some biases in policing, and police officers have a history of being racist, and non-white people are more likely to get arrested. So it's not that non-white people are more likely to commit crimes while out on parole, they're just more likely to get arrested for it. So if you train it with biased data, you're going to get biased results. And just being aware of those sorts of things is critical thinking. Hey, what is this doing for us here? What kind of data are we getting out here, analyzing your biases? And then editing and refining. Because I'm lame now and I joke around with my professors, friends, because that's all I have now. We send silly things around, and we make fun of students who cheat badly here because it's kind of amusing. Like including in your paper, your English paper is I'm a large language model. I can't answer that question, but here's like because the paper was on a personal response, hey, give your personal reflection on these sort of things. People just copy paste the output without even editing, and it's embarrassing. And then we laugh. Like if you're that lazy and you cheat that badly, you're going to get made fun of, right? Is it? Should I not be saying that out loud? That's fair. Thank you. I feel like it's fair because if you're going to cheat, you have to at least try harder, right? And honestly, I don't think using AI tools is cheating, but we want to do it in a smart way because that's what you're going to do in the real world. People are using these tools in the real world. My goal is to make sure you can do it well and don't look stupid, right? Don't give bad code to your job. Be like, oh, I don't know the AI generator. I don't know what it does when they ask you about it. That won't fly in a presentation when you're presenting code to your team, right? And then another critical thinking skill you can use is using it as a brainstorming tool, not a definitive answer generator. Like, hey, give me some examples of this or give me ideas. Like, use it and then build on it and run with it, right? That's about the only thing us humans have left now that makes us better than the machines is we can actually do reasoning. Deep think and other models don't actually reason, right? It's just feeding it through its model here. It can't actually do that. One of my buddies had a funny 15-minute screen capture of the deep think version. He gave it a physics question, and it just sat and spun and spun and spun and spun and spit out an answer. I was like, oh wait, I don't think. Oh wait, I don't think. Oh wait, let me try this. Let me look at this. Oh, that doesn't seem right. And just over like he finally killed the process after 15 minutes, and we thought it was funny. Um, but people can actually use critical thinking. Computers don't actually think, right? Large language models just say, oh, it looks like this, puts it through some processes. Okay. All right. Well, that was fun. AI stuff, vibe coding. I really hope it's not a real thing. It's just, I don't know. Maybe it's a thing because people took the joke and ran with it, and now people are doing it and like ironically. That's a thing, right? You can. Normal people who try and program. Yeah, if you don't know anything about software, the bots are cool and chatbots are nice and you can get somewhere, but it's not going to be long term, right? And whether or not it actually said it can lead to dependency and reduced learning, I feel like they faked that response. But yes, that this will happen if you just say, "Oh, this is what the machine gave me here." I don't know if it's right or wrong, right? You have to know how you can check these sorts of things here. So that's all. All right, we should get back to the Enigma machine. My apologies. I got a little bit off track there. Just kind of excited. So we're going to write some classes, and then we're going to write tests for those classes, and then we're going to make the tests pass, essentially. It's not going to work 100% because I don't know what the random sequence is going to be, but once we figure it out, then we can fix our tests. So it'll be a little bit wonky for this one, just because we're using the predetermined random stuff here, but it'll be okay. So first thing, let's do like the plug board here. Again, I like one file per class. It's a bad habit of mine, but I like it, and I think it makes my source control nice. Not everyone agrees with me, but that's okay. So we'll have a class for plug board here, and it'll have an init here. That one that takes a mappings string or something like that, right? Or pairs or whatever you want to call this here. Sure. That was my 20 characters, essentially. Now, if we wanted to sanity check it, we could say, hey, is it 20 pairs? Or we could even go, hey, is it an even number? That's 26 or less. Because technically, you could plug in as many things as you wanted here. I don't care what you went with. You didn't even have to sanity check it. You could say the input was good here, but think about these sorts of things. Right? Think about what makes sense when we're coding here. So maybe we'll just leave that as a to-do. To check for valid number of pairs here. But otherwise, that's fine. So we'll have a self dot mappings. Sure, is a dictionary. Right? This letter maps to this letter. If I put an A in, the plug board says, oh, that now turns into an E. Right? If I don't have a mapping for it, the letter doesn't change. If I put a Z in, it stays a Z. Okay, that's how the plug board works here. So we got our mappings. We'll come back and finish this in a minute here, and then we'll have a, I don't know, translate, given a letter, and we're going to return, for now, I'm just going to return a blank here, right? Translate, oh yeah, it's just suggesting it might be static. So that's about all the plug board has to do right now. So it's got an attribute, and it's got a function, and we'll come back to write the code after, right? But to test it, I should be able to create one, give it some mappings, and translate a letter, right? That's all it needs to do. So I can go write a test for it here. So let's go to test to make a new test for test to translate here. And then I want from plugboard, import plugboard, and we're going to arrange, we're going to act, and we're going to assert. Okay, so we'll have my plugboard here. So my plugboard, lowercase plugboard equals plugboard, given A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Huh? Clubboard. There we go. Forget how many letters this was here. Club equals board. My goodness. I'm going to blame my screen flickering here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. QRSTU. T? T. Okay, cool. So we got a plugboard, right? And then we should have an expected letter. So if I put in an A, it should map to B, right? We said, hey, these things should be pairs. The first two, the next two, the next two, the next two. That's how I wanted to write it here. Then act is an actual letter. Is my plugboard dot translate A. Now, these are all uppercase, sure, and that's actually how they did it in the German machine. It was all uppercase letters. We didn't have upper and lower, and that just makes life easier. Hopefully you didn't spend time trying to figure out both here. Then we can assert, self.assert equal, my expected letter and my actual letter. Yeah, if you assumed all the input was uppercase, that's great.
Or just they did lowercase, I can say dot.
Yeah, you can just take your input to upper. Right. So here's my test. So A should have to be. This will fail right now, right, because we didn't actually write the code here, but now my test fails. But I have something I can go and do now to make it pass, right? And we can keep doing this with all the different classes. So I can go add another class if we wanted here for rotor. So this is our class for rotor. It has an init here. So rotor needs the number and the position, right? You tell me what rotor number, what position you're at to start. Great. So self dot we can track whatever things we want. Maybe we know what number we are as the number. I don't really know. I mean, we're starting to write a little bit of code, but this is not all that important here. And then we need to figure out what this thing does then. So this will translate, right? Translate, given some letter, will return another letter here. And then we can also rotate these things here, right? So rotate, right? We could either rotate once or we could rotate multiple times if you wanted to have that as an option, right? So times to rotate. Start off with 1. So if you don't tell me, I'll assume it's 1. I've been thinking ahead. If I need to set it to position 25, I either have to call rotate 25 times, or I can just pass it 25 and my code will take care of it here. Both ways work. Yeah.
So for the rotor, I kind of just keep that
Yeah, so there are actual mappings. Rotor 1 has this particular letter sequence, rotor 2 has that. That's a lot of work, and I'm not into that, right? I'm going to use this rotor number and randomly generate it. It'll be a lot easier. But if you did it off this actual sequence, that's cool. You've just done a lot more work than you need to.
That grabbing that stuff working in will be less work because with the random spacing, you have to do the whole sampling thing, however you do it, and so none that duplicates.
I promise it's less work than copy pasting, but it's okay. So, and the cool thing, if you make it random here, I can now have n number of rotors here rather than I only know how to make 5. Not that we need more, but we've got the opportunity to expand beyond the original 5 without having to do a lot of extra work here. So I think the test for translate here is basically the same thing here. We're not doing a rotor though. We're not doing a plugboard. Here's a rotor. Rotor here. So we're going to say, hey, this is rotor 1 for sure, and maybe rotate 1 time or position 1. Sure. Why not? And we'll call this our rotor. We got an expected letter. I don't know. This probably is not actually correct here at some point here, but that's okay. We'll come back and figure out what the letter actually is going to be here. But I've got a test, right? At some point, we'll call rotate and test rotate, right? So here's a test for translate here. Now we can test the rotate function by essentially doing the same thing. We get expected first letter. Oh, sorry, I'm using the wrong syntax here. Casing. First letter for B, and an actual underscore letter. There we go. That's why it was yelling at me. And then we'll have an expected second letter. Again, I don't know, it's not going to be C, that's fine here, but if I translate two different letters here, there should be two different mappings, right? If I rotate in between. So rotor.rotate. So if I call rotate, the next time I map an A, it should be different, right? If I rotate it 26 times, I should come back to A again, right? So I could rotate again here, rotor.rotate. And then if I say, hey, rotate 25 more times here, that's the 26th time. It should have gone back to A, right? Or no, there's position 26. So rotating once will put it in position 2. 25 more times should put it back to 1, right? Because 27 should roll back over to 1. So then actual third letter now should be the same letter as before when I assert, right? The first letter, my expected third letter should equal the expected first letter. Right? If we rotate all the way back around, we're making sure that we get back to our original start here. Again, didn't really need to have that, but it's nice to know that that's happening, and I want to know that that works here, so I'm writing a test for it. So I'll have my actual expected first letter and my actual first letter, and we'll just copy paste these for second and third. Second, third, third, and second. Right? Does that make sense what we're looking for? Just having called rotate once and making sure I get a different one, that gives me 100% test coverage because I've called that function, right? But you can do a little bit like the testing, making sure it does all the things it's supposed to do here is also good. Um, and I know at some point I want to make sure that my code that goes from 27 back to 1 works as well. I just haven't written it yet, but I know I'll have that function in rotate. So this test will cover that piece. Like, oh, hey, when you rotated, did you go from position 26 to 1? So I want to make sure that that bit of code that I know I'm going to write will work. So I have a test for it here. So this is test translate. This is rotate 26 to 1 or something like that. And here's a test rotate or just test translate, right? Or just test rotate at all, I guess. That's fine. We're just testing rotate. Sure. So we got two tests here for this one. They'll both fail, right? Because our code doesn't work yet. Well, that's okay. We'll come back and do that. So we got the plug board, we got the rotor. Now, the reflector is like the exact same thing here, but it doesn't rotate. It's fixed, right? So we could either use some inheritance, right? That might make life easy here if we do that, right?
I assume
Rotate should pass. So I like the idea of it being inheritance. It doesn't have to be, but again, I think that makes my life a little bit easier here. So which way should this go? Right? If we think of inheritance, which one is the base version that everything does, and which one has the special version? I think the rotor is special that it rotates, right? The reflector doesn't rotate. So class rotor then can inherit from reflector here. Again, we don't have it yet, but that's okay. We'll go right in a second. So from reflector, import reflector, then it takes a number and a position. Sure, technically you can set the reflector at given positions. We didn't bother with that. We'll just have a single position. Here's we go. But this one needs to know what it is. The reflector class doesn't. The reflector class doesn't even need a number, right? It's just going to go and set up its mappings here. It'll still translate. And really, we don't even need to have translate specified in rotor if the reflector class does it, right? If it just looks at a mapping and gives you what's back here, the only thing that's special is rotate. So I'm going to take this out here, and we'll just have rotate for this one, and we'll go add that class. Again, spending some time thinking about the design before I go and write the code, it's helpful. I've done this before, so it's a little easier for me to do that. So let's say this is reflector here, and then we'll have a class for reflector. Define init here. Now, this one doesn't need anything here because it's always the exact same one, but it'll have a translate function, right? It will set up its mappings eventually here, right, based on some random sequence, right? And then the rotor will also do that same sort of thing here, right, with some sort of value somewhere. Okay, so we're going to use the number as the seed value So if the number is the seed value and I want all that work to happen, oops, that's a triple there, in init, I need to be able to pass it in here. So maybe I need a seed here, then we'll default it to 0 here, but we can pass that seed value up for this one here. So when we create our rotor, which is a type of reflector here, we have to add our superclass call, we'll init with the number. So whatever, hey, your rotor number 1, that's my seed value. Hey, your rotor number 2, that's your seed value. Your rotor number 3, that's your seed value. So it's repeatable at that point here. And I know that's what it's supposed to do here. We got translate. Now, testing for rotor, I don't even really need to test translate now because there's no translate code. Right? The only code I have is rotate. Right? That's the only code in my class for rotate. So I'm going to go test the reflector code here. Add a test for translate. So we'll go to test, make a new test here, test for translate. And this one, we're just going to paste in that code we had. Oops, too much. Now this one then is a reflector. So from reflector, import reflector, right? And then we'll make a reflector here. Now this one doesn't need any particular values here. Right, so we get a letter, we can translate, we get another one here. Okay, so now our test for rotor though says, okay, rotor, should be good. This one doesn't have to change. So I've got a couple classes, a couple tests. I don't have the Enigma machine yet, but we're getting there. Right, so the last class then is going to be the Enigma machine. Enigma. So this is our class Enigma. Find the init. Now this one takes a couple things, right? So it has rotor settings, or it has rotors, it has rotor positions, and it has the plugboard settings, right? However you wanted to take that in is great. Right? I gave you an example of here's one string with 6 numbers and 20 characters. Great. If you wanted to have 6 different prompts or 7 different prompts, that was great too. Right? Whatever you want, fine. I'm cool with. You figure that part out. My class, though, is just going to take the parameters. Right? However input happens is separate. Right? Because our code is so good and wonderful, we don't want to run this in a web application or a mobile application or a graphical user interface application because nobody uses console applications anymore. Very few people do. Mostly us computer science nerds use console-based applications. But sure, we'll take some parameters. So we'll have rotors, rotor numbers. Maybe we'll have rotor positions. Maybe we'll have plugboard settings. Right? I'll take them as 3 different ones, but this will be a list, this will be a list, and that'll be just a string. Sure. Or maybe this is a string. Right. However you wanted to do it. Right? Totally up to you. So then my Enigma class, again, we'll do something with this init here. I'll come back to it in a minute here. It'll have some attributes. We'll figure that out. So we'll have, I guess we should import here. Let's do that. So we'll go from plugboard, import plugboard, from rotor, import rotor, and from reflector, import reflector, import reflector. Okay. So it'll have a self.rotors is a list of rotors, right? It'll have a self.reflector is a reflector given nothing, right? And then it'll have a plugboard is a plugboard given the plugboard settings. That one's probably you can pass through right away, right? We'll figure out how to do this rotor thing in a little while. Right? We come back to that. And then what does this one have? What is its function here? Well, it can translate, right? Some string. Now, this one is not a letter at a time, it's the entire string, right? So we give it some string, we get some string back out, right? So again, I'm just going to return nothing to start. So our test then will test translate, right? Does the translation function work here, right? Testing one function at a time. So let's go to test, new tests, test for translate here. And again, I can mostly steal this one here. So from Enigma, import Enigma. So we'll make an Enigma. We'll say, hey, I need to give it some values here. So I'll know, hey, maybe 1, 2, 3 for the rotors, and maybe, I don't know, 7, 9, and 11 for positions. And then what was my plugboard settings here? I had that. I don't have to type it again. We'll copy paste that one here. Right, sure. So an expected, maybe this is the result, is, I don't know, B, K, D, I don't know. We'll put in hello and see what we get back here or something like that. Hello world. Sure. world. Here, we'll come back and figure this out here. Maybe we'll translate the expected. Oops, here's the starting word. We'll just give it here. Hello world. Now spaces probably shouldn't get translated, right? They actually had a sequence how the Enigma machine did it. Did they use an X? I thought it was just every like 4 letters they just had a block. I don't remember. Okay, yeah, whatever they want to use here is cool. Actual results.
They don't have that in German.
Really? Oh,
I
I, I, I took 3 weeks of German in middle school. That's my extent of my German here. Expected results and the actual results. Right. So something in here will translate to something here. I'll just leave it as hello world to start here. We'll come back and fix it.
He still says, "We're
Oh yeah, yeah. Here's our Enigma. Enigma here. Enigma to translate here. Right. So I got a bunch of tests. None of them work. I have the skeleton of my code. I've got my classes here. Right. I got full points according to my rubric. Right. Technically, yes. So if you want to rules lawyer me, I'm going to give lots of partial points here if it's not 100% working. But this is not even close, right? We've got some. So if you gave me this, I'd give you a lot of points, but not tons of them. Like, hey, I got all my unit tests. Great. You get 10 points. You got object-oriented design. Great. You can set it up. Great. But like, it doesn't really do anything when we set it up here, right? I guess that's probably the biggest parts we're missing here. Okay. And it's not been too long, right? This was somewhat straightforward. I've done it before, so I'm familiar with this design, right? And I suggested a lot of classes here. Maybe you went with it, maybe you didn't. That's okay. So now we got to make these things work, right? So let's do the plug board first. That's probably the easiest one here. So if I give it 10 pairs here, I can go and set up those pairs. So I want this is my letter index in range, the length of mappings here, right? And again, I'm going to assume it's 20. It might not be, but that's okay. So I'll take my self.mappings. I'm going to take key of the mappings at the letter index, assign it the value of the mappings at the letter index plus 1. Right? And I actually want to range this by 2. I want to count every other. So I'm going to take the first one and then go to the one next. Take the next one, go to the one next, right? To set up these mappings. So A will map to B, or whatever. The first letter will map to the second letter, right? And then I'm going to repeat that for the other direction because that makes my life a whole lot easier here. So I'll say plus 1 then is equal to the original. So now B maps to A, right? And we just keep on going through. My plug board's done. Okay. So translate now needs a little bit of work. So if my letter is in my self.mappings, I can return the mappings key of the letter. What letter does it map to? Self.mappings. There we go. Right? If it's not in the mappings, I'm just going to return the letter. Hey, you asked for Z. I don't map to anything. I just give you back a Z. Right? That's it for plugboard. Right? If it's mapped, great. If it's not mapped, nothing changes. Okay? So now my plugboard test should pass. Right? When we come here and run our tests for plugboard, let's see. Translate. Translate A doesn't map to B. Expected B, we actually got A. Okay, what did I screw up here then? A should map to the next one here. And then B should map to A. If letters in the mappings, return its associated value. That should be fine. I don't know. Let's put it in debug mode. So let's go back here and let's debug our test.
to do in the return.
Let's if it's not mapped, right? So I'm asking for a capital A. My self.mappings here should have a bunch of values. Let's see, where's my mappings? Oh goodness, I never added any mappings. Oh, I took mappings here and oh, that's self-mappings. Length of mappings?
Maybe call that one out or something.
Range, length of mappings, self-mappings, mappings.
There, right.
Yeah, it should be fine, whatever we call it. So something's wrong with the init here then. So let's go stop this here. Let's put a breakpoint back in the init method. And see what we did wrong here. So let's test this debug here. All right, so we're in mappings. I gave it a bunch of values here. So we can go through and see, is my range is wrong here. This is 0 to 2. This is a start and end point, not a every other. So I want to range to from 0 to the length of mappings, counting by 2. Because I was going, right, here's a start point is a big number, end point's a small number. It's my bad for using bad overloads here. You guys got to stop me when I do dumb things, right? Let's try it. Oh, now the test passed, right? So if I run my tests here, nope, that's the plugboard. Run the plugboard tests here. Now it passes. All right, so if we do the right thing, we actually range properly here. Life will be a whole lot better here. All right, so plugboard's done. I think. Yeah.
I don't know. About the board that put them together and we become clear as well.
Yeah, they're physically connected.
The final
Yes. Yep. Yeah, that's how it works. It was like two pairs that said translate this letter and this letter. Yep. Okay, so plugboard's done. How about we go to then the reflector, right? Because we have to figure out this. Once we do this, rotor's done, aside from the rotate part, right? So how do we set up the mappings given a seed value, right? Okay, well, I need an alphabet. Alphabet equals C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z here, right? I've got some mapping set up and I've got my seed. So I'm going to say I need random. So we're going to import random. Now, to make this repeatable, I'm going to seed it with whatever seed they give me, right? Defaults to 0 here, which is great, right? My rotors then will default to their rotor number. So they have a different seed value. So we'll say random.seed given the seed here, right? Seed it with that value so that every time I do this, it'll give me the same sequence here, okay? Now, lots of ways of going about this here. I think actually making this a list will be easier here, but it's more typing for me, which is a little bit obnoxious, but that's okay. So if I make this a list, I can grab letters and I can take them out. I can do it with a string, but then I have to like do substrings and slicings and all sorts of things, and I feel like that's a little bit annoying as well. So I'm going to turn this into a list of values here then. So this is A, we just do single quotes here, A and B, and oh, yes, thank you. I know there's a shortcut here. Thank you. There's a list of, here's the string. Perfect. Awesome. Students. I'm not going to put your name in because this goes public here, but I'll cite your source here with the list syntax. Okay, random seed. Now I want to get 13 of them, right? Pull them out and then map them to the 13 that are left. Yeah?
You have to put A and B where.
Oh, thank you. A and B. Perfect. Okay, so let's take 13. So here's my, I don't know, what do we want to call these? The first letters is my alphabet, or I want random dot sample given from the alphabet, and I want to sample 13 of them, right? I want K, 13 of these random here. I'll pick 13 random, okay? Then I want to remove those values. So I want to take my alphabet and I want to remove for letter and first letters. Let's take my alphabet and remove the letter. Okay, there's probably a faster way to do that, but that's fine. We'll go take those out. Now, there should be 13 left here then. So I've got 13 first letters, and I've got 13 left in my alphabet here. Let's go set up those mappings. So for index in range length of my first letters here, let's take my self.mappings, key of the first letters at the index, and let's associate the value with the alphabet at the index. Right, and then we'll reverse it, add in the pair, the other direction. So alphabet at the index is the key here. And then first letters at the index is the associated value. So I should have 13 pairs, right? Again, tons of different ways of going about this here. I find this is probably straightforward and easy enough, but sure, there's lots of ways here. There's not a wrong way to do it here. But because we're using the sample and we've seeded it, we'll get the same 13 values out randomly every time. And we'll map them to the 13 remaining ones every time, right? You could shuffle it and then go through and do the same thing we did with plugboard, right? Just take the first and the next, the first and the next. Maybe is that even easier?
I would use shuffle. This way, are you not giving the chance that they can be mounted?
Because I've removed it here, so it can't. Yep. Yeah, I think, so shuffles also would be good too. If we did the shuffle, then we can actually use more inheritance, which is really fun, right? Can we do that? If we shuffle it here, then we can hand it over to plugboard and pretend it's a shuffled plugboard. That's probably a little crazy, but that's okay, right? Because it does all that stuff. If we just shuffle it up and turn it back into a string and hand it to plugboard, you're like, hey, here's your 26 pairs or 26 letters, and you get a bunch of mappings. It's okay. So that would be nicer at some point, but it's okay. Should we do that? I feel like we should do that now. Let's do it now. Okay, that sounds like a lot of fun here. So forget all of this other code here, or I'll just leave that commented out here. So easier thing to do then. We've seeded it here, so we'll go and shuffle. So I want to take my alphabet.shuffle, or no, is it random.shuffle, shuffle the alphabet list here, and then my sequence or letters here or pairs or something will be a alphabet. Oh no, I want the string.join the alphabet. Right? Take all those things, join them back together with no spaces here to get back 26 letters in a row as a string here. And then I'll have so I don't even need a mappings here then. Self.plugboard is plugboard. Oh, I got to do this below here, right? Yeah, plugboard given the pairs. You got to go import plugboard from plugboard, import plugboard, plugboard given the pairs, right? And then from translate, then we're just going to return my plugboard translate the letter.
Plug will only have.
Well, we didn't actually check for that, right? We said, hey, that'd be nice to do, but it's just going to, any mappings I give it, it'll take. So we're sort of abusing the fact that we're not checking our number of pairs at this point. I thought this was a little silly, but I thought it'd be fun too. So we'll take advantage of that. So get a list, shuffle it randomly with a given seed value, turn it back into a string, hand it to the plugboard, and then, hey, we just asked the plugboard for its pairs. That's done. So now it's a random sequence of pairs. Yeah.
The shuffle guarantee. It won't actually say my line.
Shuffle just randomly sequences it here. So it shuffles up the indexes. That's all that one does. So my plugboard just says, here's the first one and the second one. They're paired. The next one, they're paired. The next one, they're paired. Yeah.
You doing your question? That's what you said. Self-assured.
Self.assert. Yeah.
Was that necessarily used for our testing systems? Right.
Hey.
So this is what I'm testing for. It's the second.
Ideally, you use the Python unit test class like we did in class. As long as you made a.
Just that one self-assert wasn't necessary for I think about.
If you're using the unit test class, that's the only thing that tests is self-asserts. Yep. Otherwise, it doesn't do anything. Yeah, so that's the bit that makes it pretty and shows you the UI and all that good stuff here. All right, so we've abused plugboard for our reflector here, but let's see if our test passed now. So test reflector, then I don't know what letter it should map to because I didn't shuffle it with a seed of 0. So if we wanted to, we can go and do that first here. I don't really want to have to rewrite all that code here, but we can, or let's just run it. Is that okay? And then we'll put in the correct letter. So say B does not map to O here, so my expected letter should be O. Right? Hey, now my test passed because A maps to O with a shuffle with a seed of 0. Sure. Again, we could have gone through and done it all, but I think this is probably easier. Does that make sense? Okay. So now our reflector's done. So now rotor, how do we rotate? Here's the hard part now. Right? We've created it here, set our number. I don't actually really need the number here, right? Once we've done it here, and we need to position. So with the position, we'll call self.rotate the position number of times and -1, right? Because at position 1, I don't want to rotate at all, right? At position 26, I rotate 25 times to get to that here. And then we'll take a self.position equals the position, right? Or even actually, like if we set position at 1 here to start, and then we call rotate here, rotate probably takes our self.position and adds times to rotate to it, right? And then we have to go and rotate. So here's the hard part here. Now, if we're using plugboard, we have to go get the plugboard's mappings. We didn't make anything private. Might have been good to make these things private, but it makes our life easier because I've got full access to it here. So all I'm going to go do is every time I rotate, I'm going to add 1 to the character. So A will turn to B, B will turn to C, C will turn to D, Z will have to rotate back around to A. That's all, right? So to do that, we can take advantage of the way we store characters as Unicode values. Right? In Python, you use the ord function, ordinal, will get you the numeric value back out. We can add 1 to it and then translate it back to a character here. Yeah.
I kind of did like usually where I have like an array for wirings and each input layer gets moved into numbers.
Sure. Yeah, and there's tons of ways of going about it here, so it's not a wrong way.
Output of whatever it's sort of the wiring. With that 10, it's out of whatever the 10 thing.
Yeah.
There it is. And then to step it, you need like pop down to the
What is that? Okay. Yeah. Yeah, that's fun too. So rotating, we have our self.plugboard, right? Because we are a reflector, we've got this plugboard setting, right? And that plugboard has mappings, right? So essentially, we're going to redo all of them, right? I'm going to get rid of the 13 pairs and re-add 13 more pairs, right? So I've got old mappings and then new mappings, right? So my old mappings is the plugboard mappings here, right? And then I want to remove all of these here. So self.plugboard.mappings. Is it clear them all out, or just set it to a new dictionary? It doesn't particularly matter here. This might be more efficient here than removing it. I don't actually know off the top of my head here, right? But then this is a key and value pair, right? So I want key and value in old mappings.values, right? I'm going to take all of those and I'm going to go add 1 to them here. So if I need to add 1 to things multiple times and I want to make sure Z goes to A, I'm going to add a little helper function for it here. So we'll define a, I don't know, step letter, given a letter. So we're going to take the letter, translate it into its ordinal value, add 1 to it, turn it back into a character for everything except for Z, right? So maybe it's just, hey, if letter is equal to Z, we return A. That's my special case here because I don't want to have to do any of the other arithmetic. Otherwise, I'm going to return the ordinal value of the letter plus 1, turn back into a character, which is sure in Python for reasons I don't know why. This gives you the ordinal value, the Unicode value for that character here. Yep. So lots of ways of doing it. You could have done all 26 mappings here, but again, I'm lazy. I don't want to type if it's A, return B, if it's B, return C. Right. This is just my little shortcut here. Again, lots of ways of going about it here, but there's one option. So now I can step on my letters, right? So for every value, then I'm going to take my self.plugboard.mappings. Oh my goodness, that was wrong. Self.plugboard.mappings. Key of the key translated here, right? So I want step the, oh goodness, I'll take key equals self.translate or step letter given the key, and value is self.step letter given the value, right? And I'll say, hey, the key associated value of the value here. And again, because we're pairs, I'm going to do it in reverse as well. So, hey, key of the value, associate the key, right? So take the old ones, increase them by 1. That's how I step, right? And we do that then for number of times you have to do this, right? Sure, we could step by more than 1 if you wanted to step the letter, but then my arithmetic, it's a little funky here. We'd have to actually check that and like mod the particular value, and I don't know. It's probably more efficient, but I'm feeling kind of lazy here. So we'll say for rotation in range times to rotate here, and we just keep on repeating this, right? Terribly inefficient, but it's okay. We should clear it out every time, right? I think we need to do that every time. Terribly inefficient. We've made 25 dictionaries if we rotate 25 times. I feel a little bad. Feels bad. This is inefficient. I can't even spell inefficient. There we go. It's probably close. It's okay, right? So we could fix it up and make step letter be a little bit smaller and those sorts of things, but sure. I don't really care right now. Is that okay? We're just stepping that many times, right? So now rotor should work, right? Again, I don't particularly know what it's going to come out to be here because I don't know what the mappings will be for a given seed value yet. We could go work it out by hand here and then add it in the tests, or we could just be lazy and test our rotor here. Let's go run this one here, and I'll see what it should be. So test for rotate. B should map to Q. So this is for first letter. So expected first letter should be a Q here. And now let's run it again. And now expected second letter should be a C. I'm sorry, should be an A, right? And then if I run it again, test rotate, second, third letter, and third letter, Q doesn't equal A. Expected, did I do this wrong? Rotated 25 times? All right, this one doesn't seem like it's working right, because after we rotated, we should have gotten back to the Q, right? If the first one was Q. What did we do wrong here then? Did it not? Well, it gave me a different letter, right? Expected a Q, it actually got it. So it didn't rotate 25 times? Maybe we're not actually rotating a bunch here. For rotor, rotate times to rotate. Oh, we never fixed the other position thing here too. So if this should be, if we add 25, it went to 27, right? So we never fixed that one. So if self.position, yeah, is greater than 26, self.position minus equals. So if it's past 26 and it got to 27, we should subtract 26 from it. Right, 27 should go back to 1. If we stepped a whole bunch of times, it should, whatever that value should be. But again, but I don't want position 0, so I'd have to and then add 1 to it. I don't know.
Also, don't you need to increase the position number each time you go through the rotation?
I did it here, just all of them. We could do it one at a time in rotate. So if times rotate is 1, this should do it 1 time, right? For when it's 0. Old mappings, clear, get the values, reset the values here, key value. It should do it here. Why is this not stepping right?
Set key value again.
I don't know. I'm not really sure here. Let's rerun the test. I wanted to debug the test. Back to test here. Let's debug it and see what it's doing. So the first rotation here, right? We already have a knit here. That's fine. We can continue. All right, so we're in rotate. So we're rotating the first time here. It should be set up. Excuse me. Oof. All right, so here's all of our mappings, right? So A and Q. Cool. So we've got that. Now we're going to go and rotate that from A and Q. And the position didn't change that much, right? So position only went up to, did it not add at all? Times to rotate was 0. Oh. Times to rotate is 0. How do we get a times to rotate 0?
Didn't you default it to 1, maybe you didn't put 1 in that in the actual game, I don't know.
So where's our test here? Test Enigma. Oh no, test rotor. So when I called rotate, it should have given me 1 as a default here, right?
Maybe just put 1 in there just so you know that's it.
Oh, it's we created. This is still in. We created the rotor is where we are in the knit here. We're rotating it to position -1. Okay, that's what happened here. So this is from a knit. So it's supposed to be 0. It's not supposed to rotate at all, right? We just said, hey, start yourself at this position here. That's my bad. I wanted when we made it for it to rotate itself, but it shouldn't rotate anywhere here. So if we step, yeah, nothing happened, right? So now we still have A to Q. So we've got A returns a Q, translating that letter. Right, and now we're actually rotating here where times to rotate is 1. Okay, so now we should rotate 1 time. Position went up to 2, which is good. And then we're ranging over 1, so it should rotate 1 time. And it should set up all those plugboard values here, so they should change. We'll see all these things change. We're at position 2. Now we got A is returning that one. Okay, and now we want to rotate 25 times. Is this not... This is my problem here. I think clearing this out was bad because I didn't get a copy of this one, right? I think that's what happened here. So we'll go back, position. So now position is back to 1, which is good. We're going to rotate old mappings here. So I have old mappings, which is an empty dictionary. Because we cleared and I made a shallow copy here. This is my fault. I screwed it up, right? Once we rotated, we cleared it out. So this was dumb here. So I shouldn't have used clear mappings equals a new dictionary, right? Now I didn't clear out this old mappings, right? If I said old mappings equals this dictionary, now I have 2 variables pointed to the same dictionary, right? It doesn't actually make a copy. That's the shallow copy. Thanks, pointers. We love pointers. I think this will probably work now that we're not deleting our mapping. That's why it mapped back to A, because it was gone. Right, for the second one. Does that make sense?
To not see the water.
Even more inefficient, yes. Sure. I mean, processing power is cheap, right? We'll never notice the difference here for this one. So test our rotor. Let's run our test again here. All right, so now we're getting a different one here. That's okay. Oops, key value and old mappings values. Not enough values to unpack here.
Because there's no key values, one is empty.
It should have given me those, right? Mappings. All right, let's put another breakpoint in. This is getting fun here.
Wasn't it supposed to default to non? If there was nothing,
All right, so this is our initial, we're rotating nothing here. That should be fine. There's our init. We're done. And then we get back to mappings here. Let's just continue. All right, so now we're rotating one time. So we've got plugboard. It's got all the mappings. Let's see if it rotates one time here. Old mappings is the mappings, right? We got our old mappings. Set the plugboard mappings to blank. Right, this is blank now. Good. And then for key and value in the old mappings, oh my goodness, it's not values, it's pairs here, right? No, old mappings dot, it's items here. Values was just the values associated with the keys here. I wanted the items, gives me the keys and values here. Right, you guys got to catch me when I do stupid things. Come on, you're bad. You're having trouble with that here. Try it again. All right, now we're getting okay. So now it should be G. I'm assuming is the second expected letter here because now we've actually mapped something. It was giving me A before because I'd blown away all the mappings, and plugboard says if you're not mapped, you get your original letter back, right? And now it passes. So we get a Q, we get a G, we rotate 25 more times, we get back to a Q. Life is good so far. This is why we write the tests, right? I can debug my tests and make sure my code actually works. Right? Last one here is Enigma. What do we do here? Right? Well, I need to actually figure all this out here. So I've got rotors then. So for index in range, length of the rotor numbers here. Yeah, we should probably make sure sanity check these things, but again, sanity check rotor and positions here. That's a to-do. We'll come back to that. Maybe we'll let the chatbot take care of that one for us. Hey, chatbot, fix all my to-dos. Wouldn't that be nice? Just vibe it, right? All right, so we'll take our self.rotors and we're going to append a rotor given the rotor numbers at the index at the position of rotor positions at the index. Right? Make a bunch of rotors, put them at the starting positions. Right? First one, second one, third one. Now, the only problem is when we translate the letters, they have to go in the correct sequence. Right? So if the third rotor is the rightmost rotor, I have to hit that one first, and then the middle rotor, and then the left rotor, and then the reflect. So it'll be a little bit of work here, but that's okay. Excuse me. All right, so we should be able to do that one here. Reflector is great. Plugboard gets the plugboard settings. We should be good to go. Now translate. Right, so we're going to have a result is some string here, and we'll keep on adding to it as we go. Right. Again, this is probably not the most efficient. Making strings and adding to strings is terrible, but that's okay here. To do this better. Sure. I'm feeling really bad. Okay, so let's make it a list here, and we'll go add the list here. All right, that's already we're going to be so much faster. So for letter in some string here, we're going to take results and we're going to append. Well, not quite yet. Right? We're not ready quite yet here. So we're going to take the letter and we're going to move it through all of the steps then. So letter then will equal my self.plugboard dot translate the letter. First mapping done, and then letter equals self.rotors index of what? Well, I can go 2, 1, 0. I could put a loop in here if I wanted. That might be nice, right? So for rotor index in range, the length of self.rotors, but I want to go from there down to 0, actually down to -1, stepping by -1. Right? So this way I'll start at 2, give me 1, and then give me 0, so I can go right to left this way here. We'll take my letter. It'll equal the self.rotors at the rotor index dot translate the letter. right? So this should give me 2, 1, 0, right? And then we'll take my letter, it'll equal the self.reflector.translate the letter, translate through that, and then we're gonna go through the rotors again, now the other direction, right? So now I just get to do the normal way here, translate the letter, back through the plug board again one more time. Then I can take my the result, and we'll append the letter. Okay? When all of that's said and done here, then we can return the empty string.join the result here, right? That way I build a string one time instead of making n number of strings, right? Well, we haven't rotated yet though, right? So for every letter we want to do this, now we need to go and rotate. Either before or after, I don't particularly care. I think before is proper based on what the machine does because it's a physical, when you push it down, that does the rotate mechanism. I don't care if you did it before or after, right? But maybe we should do it before here. So I need to rotate these things. Now, this is a little bit awkward, but that's okay. So I'm going to add some special case handling here. I'm going to feel bad about it, but it's okay. We could do it smarter. Again, this is to do like this smarter. It's okay, right? We'll just get the job done here. So we're going to take our self.rotors, index of 2, right? That's the third one here. We're going to call rotate. Rotate it one time, right? Once we've rotated it, if my self.rotors at 2 dot position is equal to 1, self.rotors of 1 dot rotate, right? If that one rotated, rotors of 1 dot position equals 1, right? If that one went from 26 to 1, make my self.rotors of 0 dot rotate. This is where I feel bad here, but that's okay, right? It'd be nice to make this flexible and I could have n number of rotors and make this ridiculous. It wouldn't be too hard to do this with a loop. It just takes a little bit of extra time here, that's all. Right, let me get our result back out. We are about out of time here, I'm sorry. So hopefully this runs now. So we'll test our Enigma, give that a run. We're gonna get some gobbledygook here, that's okay. Oops, list index out of range, shoot. Rotor index. Enigma index out of range here. Rotor index from, there is no length of 3. That's -1 here, because length is 3. I want to start at 2, go down to -1, but don't not include -1 here. Let's rerun it one more time. All right, so this should be hello world here, and it's nice the way I use my plug board here. I get the spaces for free because the space is never mapped here. It never gives me a space. So I run that here, and we get water doing. So just to see if it works here, I'm going to put a 4 in for a second, and it should give me a different result here, right? Here's a different output, right, with rotor number 4. So I think at least changing the rotor number seemed to be doing something here. We could test it all out later, but I think we're pretty good to go. Sorry, I'm running a little bit over here. That was Enigma. Shoot, we ran out of time for other stuff here. We'll pick it back up on Tuesday then, okay? Midterm review, right? Yeah, I'll post it in Canvas and put a link for you a little bit later for that, okay? All right, thanks, folks.